Okay, so we have these operations with functions. This is exactly what I'm going to be looking for. 3 steps. Rewrite it, substitute, simplify. So from last week, we have addition, f plus g of x means f of x plus g of x. Rewrite it, then you do the substitution, then we simplify. Subtraction, f minus g of x. So function f of x minus function g of x. F times g of whatever of x means you're going to multiply f of x times g of x. F over g of x, you divide. F is the numerator, f of x over g of x, as long as the denominator does not equal 0. Now there's one more common composition of functions, and that would be the example 12 over there. So we're just going to take this just a few at a time. Any questions about 1 or 2? It's like going to the item, 1 or 2. 1, 2, 1, 1 or 2. Any questions about 1 or 2? Substitute, simplify. Just like your quiz. Careful with the negatives. Okay, what about 3 or 4? Yes, can I see 3? Number 3. So f plus g of 10. This is what I want to see when you do this problem test. Number 3. So function f plus function g of 10. The first thing I want to see is rewrite this. What does it mean? It means you're going to take function f of 10 and you're going to add g of 10 to that. Rewrite it. Literally just rewrite what that means. And now we substitute. Plug in 10. Don't substitute and simplify in one step. Just substitute. So f of 10, if we plug 10 into the f function, it's going to be multiplied by 3, and then you take away 2. So when we plug 10 into the f function, it's 3 times that 10, and then we're going to minus 2. Now, here's where it happens. If you're adding, addition will not mess with you, because addition is not going to change signs. What will change signs is subtraction. So it's not going to hurt if you use parentheses with addition. But if you don't put parentheses when you subtract, it will hurt. So if you get into a habit of just using parentheses, this f of 10 plus, you'll use parentheses when you have to have it, this g of 10. The g of 10, whatever goes into g, you're going to square it minus 3 times that. So 10 is going to go in. So that's 10 to the second. And then minus 3 times that 10. So this is f of 10, and we're going to add g of 10 to it. So now we figure out what is f of 10. 3 times 10 is 30. Minus 2. And we're going to add g of 10, which is 100, minus 30. So this is equal to 28. And that's equal to 70. 28 plus 70 is 98.
Do each side one at a time, and then where it says that plus G.
That's what I hate. Real passion. And here's why. I see it all the time. They do F over here, then G over here, and they try to bring them back together, and they don't know what to do with it. They'll multiply it. They'll put one in front of the other when it should have been the other in front of the other one. They'll forget what to do when they bring it down. So that's when you're working the thing, left to right, like a typo, left to right. In carriage return, bring it down, left to right, bring it down. What is this equal? So it's always one layer under the next one.
Not so much there.
From left to right. So what he was saying was, and I see it all the time. And when I'm trying to follow your work, where things coming from? F of 10 over here, they'll work out what F of 10 is. And then they'll try to work maybe over here, G of 10. And then they get those answers, and then they try to bring it back down here to do whatever. Sometimes they forget to bring it down and do whatever. It's kind of like I just did two problems. That's it, right? They don't remember to go back and put it back together. What was the original question? And so you just keep it in line with the original question. Expand it, rewrite it, then you just substitute and you work from there. The parentheses is basically you doing that over there. Instead, you're doing it right underneath. So you can see that this is your F of 10, that is your G of 10. And it's a habit. And I've graded so many of those where it just doesn't work out. It comes out wrong. Some of it does work out, but it's not consistent. It really isn't consistent. And I'd love to see who's tutoring that. Because I know it's coming from somewhere. It really is. I know it's coming from somewhere, and I go on. I don't want it. Because they're getting lost when they're supposed to bring it back down. I got this thought, let's put it back together down here. And if you watch all the rest, if you see any of these other ones, I'll do it the same way over and over and over. Okay. It is consistency. And that's, again, that analogy about practicing, the analogy about any kind of sport. You want to practice it the same way every single time. Before you even think about improvisation. You know, you have to get the fundamentals down, and then you can think about, all right, maybe I can just combine a few steps in. All right. 5 or 6. 6. Number 6 is function J minus function G of X. Negatives. You know something's coming wrong or something coming your way bad when there's a negative, which is parentheses. You got to remember when you're going to subtract, parentheses are going to be really important. First thing though, rewrite it. J minus G of X means function J of X minus function G of X. Subtract the functions from each other. One minus the other. And then step 2, substitute. So J of X. Well, I don't have anything that I can actually plug in for X. J of X is 10 minus X squared. That's what J of X is, so that's what I'm going to put right here. I'm going to substitute parentheses 10 minus X squared for this J of X. Minus G of X is X squared minus 3X. So I'm going to subtract parentheses this whole G of X function, X squared minus 3X. So that is how you would rewrite or substitute J of X minus G of X. Now it's just order of operations. Parentheses first. Well, there's nothing I can do in this parenthesis. They're not like terms. So I can drop this first parenthesis. It's 10 minus X squared. X squared minus 3X. They're not like terms. I can't do anything in here. But I'm subtracting this parenthesis. So I'm going to distribute the negative. This is like having -1 times X squared minus 3X.
So you distribute the negative and it's going to change the signs of what you have inside. Everything is going to come out opposite sign. Negative 1 times x squared, that's now minus x squared, negative x squared. A negative times a positive x squared is now negative x squared. And a negative times a negative 3x, a negative times a negative is now a positive 3x. Then the last step is combine like terms. Simplify, substitute, simplify. J minus G of X is equal to, you want to, if you're going to put it in the correct order and get used to putting it in the correct order, you want the highest power, the largest degree of variable first. So the variable's X, what's the biggest power of all those X's? That's it. So we're going to gather all the X squareds to them. We have negative 1 x squared, we have another negative 1 x squared, negative 1 and negative 1 make negative 2 of those x squared. And then we have x to the first. We have 3 of those, positive 3 of those x to the first. And then we have a positive 10 constant. Which go back. X to the second, x to the first, that's x to the 0.
How come the x squared minus x squared, it wasn't like x to like 4 to 5? Maybe add or subtract those exponents.
I should play, you know. I shouldn't. That was further. Okay. What is x squared times x squared? What do I do there? Or multiple. Rules of exponents. The first rule of exponent was a to the m times a to the n, multiplication. That's when you add your exponents. So this gives you x to the 2 plus 2. That gives you x to the 4th power. Because this x squared is x times x. And then you have this one is x times x. So you have x times itself 4 times. So x to the 1. Because it's multiplied. None of the rules of exponents had anything where it was plus in between or a minus in between. So when you do this, let's say if only what you're asking about is actually if it would work, this would be awesome. This would be fun. What is $10 plus $10? How come I can't just go 10 squared and get $100? Because if you're saying you want to multiply and you're going to get power of 4, so I should be able to go here and get a power of 2. But I'm not multiplying the 10s. I'm not multiplying x squared times x squared. This is just 1 times x squared plus another 1 times x squared. So I have a total of 2 of x squared. I'm not multiplying the x squared together, I'm just adding how many I have. So here, I have negative 1 of those x squared, another negative 1. That combines, we keep the power. We keep the power and add up the coefficient. The only time you're going to change the exponent is if you multiply the base. Then you add 5 or divide in the base. Okay. But that's a really good question because of what happens. I'll see it. Otherwise, I should be able to go, this is the next to the third. Because if I can add x squared and x squared, get x to the fourth, why can't I do an x squared and an x and get an x to the third? You know, what's gonna stop me? Because if it applies to x squared, it should apply to everything. And it doesn't. What else? Okay, that was. Any problem, Todd? Okay. What about 7? Problem 7? Is that 7? Yeah. Okay. I saw this on some of your quizzes. And it worked. You guys showed really good patience and perseverance. It didn't work. You can find it clearly showed it. It was this quiz. The quiz where g of x was 2x plus 3 squared, and you had to do something like, what is g of 6? And I saw, I think on 1, maybe 2, less than a handful. They plugged in the 6. So they go 2 times 6 and then plus 3, and they square it, and they got the 12 plus 3, and they squared it. But then they did this. So that's equal to 12 plus 3 times 12 plus 3. So they get 144 plus 36 plus another 36 plus a 9. So that's 144 plus 36. That's equal to 180. 180 plus another 36 is equal to 216. 216 plus a 9 is equal to 225. Well, how about you just do 15? Well, plus 3 is 15. Squared, which is 225. I mean, it is a number. Order of operations, if I can keep working in here, keep working. It's easier to go, keep going, 12 plus 3 is 15, then you start at 225, then trying to pull this out, but guess what, it works. Well, that has to. Okay, math does that. So when you see number 7, this is what I've seen on the exam. This is what I hope you don't do. J times G of 10, step 1, rewrite it. This means J of 10 times G of 10. So J times G of 10, substitute 10 into the J function. So 10 goes in. It's going to be 10 minus x squared, so 10 squared. Parentheses. 10 minus 10 to the second. G of 10, you're going to plug 10 in here. Well, that's going to give us whatever goes in, you're going to square it, so 10 goes in. 10 to the second minus 3 times 10. So J times G of 10 is equal to, in the parentheses, this is 10 minus 10 squared is 100. Now you see why it's not a positive. Everybody okay with the fact that it's 10 minus 100, not plus?
I give you two reasons. Number one, that negative is not in parentheses. The only thing being squared is the 10. Number two, order of operation. Addition or subtraction happens last. You do this exponent before you ever do the subtraction, so it stays 10 minus 100. And then this is 100, 10 squared is 100, minus 3 times 10, that's a 30. And then I've seen you start to FOIL that thing out. You came so close, and they start FOILing things out. It's messy. Order of operations, keep it going. J times G, 10. 10 minus 100 is negative 90. 100 minus 30 is positive 70. So J times G, 10. A negative times a positive is going to be a negative. 9 times 7 is 63. A 0 with a 0, 2 zeros. Well, I'm not ready to go there. So we're just looking at number 7. That's all I want to ask you. What about number 8? Right? F times units. So when we expand it, this means function f of x times function g of x. Multiply it in terms of x's. So rewrite it. And now we substitute. F times g of x is equal to function f of x is 3x minus 2. Parentheses 3x minus 2, because I'm going to multiply this function times g of x, that whole thing, so that's got to be in parentheses. X squared minus 3x. This is f of x, that's g of x. I'm writing it right underneath it so I see my substitution. And when we multiply that together, we're going to distribute. So f times g of x. So each one gets distributed one at a time. 3x is going to multiply with each term. And then we're going to distribute negative 2. So 3x times positive 1x squared. So 3x times x squared is 3x to the third. Then 3x times negative 3x. A positive times a negative. 3x times negative 3x is negative 9x to the second. So we distributed the 3x. Now we distribute the second term, the negative 2. Negative 2 times positive x squared. So negative times positive will be a negative. 2 times x squared. 2x to the second. And then this last term times that last term. This negative 2 times a negative 3x. So a negative times a negative. That's going to be a positive. 2 times 3x, 6x. Questions on that stuff? So we combine my terms to this out. F times G. Of X is going to equal. The biggest power is X in the third. Gather up all your X cubes. There's only one term with an X cube. But there's 3 times X, so 3X to the third. And then gather up all your X to the second. Negative 9X squared, negative 2X squared. So negative 9 and then negative 2 make negative 11X to the second. And the last one is a plus 6X.
Substitute and simplify. If I have 3 red pins plus 2 blue pins. They're red pins and blue. I don't get 5 of purple. I can't combine them together. So 3 red plus 2 blue. They're not the same kind of thing. So the definition of like terms, when we say the word like terms, combine your like terms, they have to be exactly like each other. And what determines that is the variable part. The variables have to be exactly the same variables, letters, and their powers have to be exactly. So I could have negative 12, a to the 5th, b to the 4th, c to the 7th, all over q to the cube, p to the 3rd. And I want to add, let's go 9, a to the 5th, b to the 4th, c to the 7th, over q, p to the 2nd. Not like terms. All the variable parts have to be exactly the same. But if this was a p to the 3rd, then what I have is negative 12 of those and positive 9 of those. They're exactly the same kind of thing. It's like saying I have negative 12 blue pins and positive 9 blue pins, so that's negative 3 of those blue pins. If they're exactly the same kind of thing. So the variable parts have to be exactly the same kind. Okay, what about 9 or 10? 10. 10? Okay. Quotient. F over H. Now that's definition. If you're dividing F over G of X, the numerator is just F of X and the denominator is your G of X. So when we rewrite this, the numerator is going to be whatever F of X is, and the denominator is going to be whatever H of X is. So F of X is 3X minus 2. And H of X is 5X. It doesn't simplify. You cannot cross those X's off. You can only reduce common factors, and factors means multiplication. So what's preventing that to be, from being crossed off is the -2. In order to reduce the X would have to go into the whole numerator. X is not a factor of the whole numerator. It's only a factor of the 3X. So you cannot reduce that X. So don't. Okay. Sometimes we do things that, I mean, honestly, I see it
You do things that in your head you think is supposed to happen, but it doesn't. It doesn't work that way. If you haven't factored, you can't reduce it. Okay, what about 10? 10?
No.
Now we're okay there? Okay, we're better than 10. All right, yes, okay with 10, right? Well, so 12 is the new. 12 is what we're gonna finish up with 1.6 today. 12 would actually be written like this. That's how 12 would actually be written. And this is called a composite function, a composition of functions. A composition of functions. And the way you read that from left to right, it's H, it's called a circle. H circle F of -2. H circle F of -2. And when you rewrite it from left to right, H is the outer function. Inside the H function, from left to right, the next one is F. F goes inside the H. F of, so H of F, and then what comes next is that -2. So this is what the rewrite looks like. Here it is. Rewrite it. So you can do the substitution. And this is where I hope it makes sense. It's order of operations. When you really think about it, it is order of operations. From left to right, I want to plug something into H. What am I plugging into H? This. Which means I got to figure this out first. You got to work from the inside out. I'm going to plug something into this H function, which is here. So I got to figure this out, and then I'll plug it into this. If you've ever filled out your taxes, I haven't done it a long time, but you fill out line 4. And then somewhere, take this answer and put it down here on line 11. You're going to do a function on line 4 and then use that answer in another function later on, line 11. So I need this answer so I can plug it into the later line 11. You start on the inside. We want to figure out what is F of -2. So we plug -2 into the F function. We get 3 times -2, and we take away 2. So that equals -6. Take away 2. So what's that equal? -1. So F of -2 is -8. Step by step, rewrite it. Did that. Substitute. I plug -2 into the F function. I simplified it. Now I know that this right here is -8, and you do it again. Now I know I'm taking H of -8. How did I get -32? Oh, it's F. Wait. I wrote it wrong. F of H of -2. I wrote it backwards. I'm sorry. I'm going to finish this one. I'll come back. This is not 12. This is 11B. Or this is 12.0 or 12. Yeah, 12.0. You see how that's F and then H is on the inside. And over here I wrote H first, so F is on the inside. So I know what the inside is. I know that this equals -8. So now I know what I'm going to plug into the H function. Whatever goes into H, 5 times X. So this is just 5 times that, -8. And we get -40. So this H circle F of -2 will equal -40. You gotta plug the inner function, plug that stuff in, figure it out, and then you take that answer and plug it into the outer function. Number 12 would actually. F circle H of -2. Because F is on the outside, so F would be first in the circle of the page. So that's how you would see the question. So we rewrite it from left to right. The outer is F. And inside the F function, we're going to plug in H. And inside the H, we're going to plug in -2. I want to plug something, F of something. So I got to figure out this something first. I got to start in here. H of -2. -2 goes into H. Whatever goes in, it's 5 times that X. So this is 5 times that -2. What's 5 times -2? -10. This is -10. So now we do the next step. We now know we're taking F of -10. -10 goes in, 3 times X minus 2. So this becomes 3 times that -10 minus 2. So there's -30 minus 2, -32. Right. There's some difference, like number 8. We didn't use a number, we used X. Number 10, we used X. Number 11, we used X. H circle J, X. So when we rewrite it, the outer function is H. What am I plugging into the H function? First, just rewrite it. What goes into what's going to go in here? J of X. First thing, just rewrite it. What does this mean? It means this. just like over here. The first thing I did was just rewrite this notation as of h of -2. I didn't do any substitution, didn't do any calculations, so just rewrote it. Now we'll go and figure out these things. We gotta figure out what is j of x. Well, j of x is what? 10 minus x squared. That's all I need. Which is fine. That's what this is. That's all you gotta work with. This is 10 minus x squared. Step one, rewrite it. Step two, substitute. So now this is h of 10 minus x squared. So now we're going to take 10 minus x squared and we're going to plug it into the h function. What does h do to stuff? What does h do? Anything that goes in, what do you do? In the h function.
Opposite signs?
No.
Oh.
What does the h function do? Anything goes in, what happens to it?
Multiply.
Multiply by who? By 5. Whatever goes into h, all you're going to do is multiply by 5. Whatever I plug into h, we're going to multiply by 5. So I'm plugging this into h. So what comes out is equal to 5 times 10 minus x squared. So that equals distribute 5 times positive 10 is 15. 5 times negative x squared is negative 5x squared. So h circle j of x is, this is perfectly fine to write it like that, 50 minus 5x squared. But again, it's always important to know that we write the biggest power first. This would be better. A negative 5x squared and then a positive 50. I'll take either one. If you're worried about messing it up and getting the wrong sign, then leave the first one. Substitute, simplify. Let's do another. Rewrite, substitute, simplify. I have to see you do the rewrite. You want to get it correct. Let's do the circle H of X. Try that. Take care of my possible legs. David, very good. You here. All right. That's all right. Javier. Vanessa. Rewrite. So who's on the outside? What is the outside function? Is it G, or the H? G. So G is on the outside. G of what is going inside of G function? H of X. So we have to do the H of X first. So H of X goes first. So G, circle H of X is equal to, actually, don't worry about it. Down H of X is just 5X. So I'm going to replace this with what it equals. It's a 5X. So I'll make that substitution and I get G of 5X. So I'm going to do that down here. So when 5X goes into the G function, and you guys did stuff like this in 1.3. The third question on your quiz, you plug things in like X plus 3 or X plus 2. You plug in something other than just a number. Or whatever goes in, you just substitute. 5X goes in here. Whatever goes in, I'm going to square it. So that 5X is going to get squared. Parentheses, so you square the whole thing. Minus 3 times. That X is going to get squared. So 5X squared. Multiply by 3. So we get 25X in the second minus 15X. So this G circle H of X is 25X in the second minus 15X. When you make a composition of those two functions, when you put one function into the other, that's what it comes out as. Going back to 10. And we'll share that with the rest of the class.